In question 9, we're told the curve width equation y is equal to x squared minus 32 root x plus 20, where x is greater than 0, has a stationary point P. We're asked to use calculus in part A to find the coordinates of P. The question carries 6 marks. I'm going to state that for a stationary point, for SP, the gradient function dy by dx will be equal to 0. The first thing I'm going to do is rewrite y and have the root of x as x to the half. I'm then going to differentiate both sides of the equation with respect to x and set it equal to 0. So y is equal to x squared minus 32 x to the power of 1/2 plus 20. So dy by dx, differentiating both sides of the equation with respect to x, will be equal now to the derivative of x squared, which is 2x. The derivative of minus 32x to the 1/2, we multiply down by the power and drop the power by 1. So we'll have minus 16x to the power of minus 1/2, and then when we differentiate a constant, we get 0. Now at this stage, I'm going to set dy by dx equal to 0, and I'm going to write this as 2x minus 16 over x to the power of 1/2. You certainly don't need to, but this is one approach. At this stage, I'm going to write 16 over x to the power of 1/2 is equal to 2x. Dividing both sides of the equation by 2 and multiplying both sides of the equation by x to the half, we will have 8 is equal to x to the power of 3/2. I simply add the powers. We need to solve for x, so we can raise both sides of the equation to the power of 2/3. So 8 to the power of 2/3 will be equal to x. Therefore, we take the cube root and square, and we can see that x will be equal to 4. We now need the y coordinate, so we simply substitute in here. So we can say that y is equal to 4 squared. Then we're going to have now minus 32, the root of 4 plus 20. So this gives me that y is equal to 16, the root of 4 is 2, minus 32 times by 2 is going to give me minus 64, plus now the 20. This is going to leave me that y is going to be minus 28. So we can write that P has the coordinates 4, minus 28. So first part done for 6 marks. Few different approaches here, entirely up to you. As long as you're showing full workings to find x is equal to 4, you will be awarded the marks. Remember, we do need to find the coordinates, so sub in to find y. In part B, we need to determine the nature of a stationary point P for 3 marks. If we have d2y by dx squared, which is the second derivative, less than 0, we can say that we have a max. If it's greater than 0, we have a min. If it is equal to 0, we need to investigate further. So we have dy by dx. dy by dx is just here. So what I'm going to do is write dy by dx is equal to 2x minus 16x to the minus half. So to find the second derivative, we need to differentiate both sides of the equation again with respect to x. So on the left hand side, we've got d2y by dx squared. Differentiating 2x with respect to x will give me 2. I need to differentiate minus 16x to the minus 1/2. So I multiply down. That's going to give me plus 8x, and we drop the power by 1, which is minus 3/2. If we now go ahead and sub in the x coordinate, which is 4, we can see now that when x is equal to 4, d2y by dx squared, the second derivative, will be equal to 2 plus 8 over now 4 to the power of 3/2. I've written this now with the negative power as 1 over that. So from this we can see that this is going to be 2. If we take the square root of 4, that's 2. If we cube it, that's going to give me 8. That's going to be 2 plus 1, which is 3. Therefore, this is going to be a minimum as it's greater than 0. So all we've done, just writing down, it's greater than 0, therefore it's going to be a minimum point. We differentiate once more, we sub in the x coordinate. I might not need to show all of this working, but we simply show that this value, whatever it is going to be greater than 0, therefore it's a minimum point.